welcome everyone. So this is the third part of our series of understanding of the graph databases. Okay, so in this part 3 we are going to understand the different types of databases and why the graph database really required, what are the use cases graph databases serve. Okay, so that's the motivation here, and let's get started. Okay, so overall we are going to see the data types, okay, in general, okay, like relational, non-relational and vector databases, and then we also see the different types of graph databases exist. Okay, and then we'll see why the graph database is really required. Okay, yeah, great. So let's get started. Okay, so majorly, if you want to divide the overall databases into 3 to 4 types, you can get relational databases, non-relational databases, and vector databases. Okay, and the fourth one is the graph database. Okay, so here in case of relational databases, some of the examples you might have heard about SQL, PostgreSQL, etc. Okay, these are good. Okay, but in case of relational databases, your data what you are storing should be in a very structured and known format. Okay, you cannot change every other time if the new data comes in. You have to follow the proper structure. Okay, this is the one of the limitation, I would say. Okay, if you want to go ahead, but it also has a advantage having acid compliance. Okay, acid compliance means like you don't have the problem of the transactions the transaction being two transaction being interference from each other. Okay, those things interference may not happen. Okay, and the isolation of every the isolation also being maintained very well. Okay, and also it is very fast, and every state of your data processing will have the valid state. Okay, so some of the benefits also exist. Okay, and in case of non-relational databases, some of the example or the famous example is MongoDB. Okay, and the data type is maybe like you can take XML or JSON. Okay, so this is the format of data, like a document it can store. Okay, but the benefit here is you don't have to worry about the schema, and if you get any new data, and if you want to extend it, it is possible to extend it. You can extend the data. Okay, and that's the one benefit I would say here. Okay, but it comes with the cost of not complying to the fully acid compliance. Okay, that's one issue. Okay, and the use case is when you are having a big data and you want to maintain it and extend it. In that case, the non-relational databases are very good. Okay, like Cassandra also in the Apache ecosystem is also one of the good application. Okay, so and when it comes to relational and non-relational databases, we need to follow very strict query. Okay, for example, okay, if I want to query my data, okay, I need to write a specific format. Okay, I cannot like English like language. I want data, just search for a data having so and so property. I cannot do that. Okay, so I need to write a proper query which follows some instruction, like MySQL query. Okay, or MongoDB query language. Okay, those I need to follow. Okay, in order to search for the data. Okay, this is something we need to strictly follow. Okay, but what if you want to don't follow, if you want to write your query like in case of English like language. Okay, natural language. Okay, in that case you need something, another type of database what we called vector databases. Okay, and here basically what is going on is when you are having the data, we are going to extract the features, or we say take the data into another space or embedding space. Okay, extract the embeddings by applying some DNN models. Okay, or deep or AI based model, and extract the embeddings out of it, a vector representation of your actual data, or actual data may be images or video, or it can be text as well. Okay, or sound. Okay, it's up to you. Okay, convert it into a vector representation. Okay, numerical representation, okay, and then store it and try to query on top of it, okay. So this is the one advantage we are getting in case of vector database. So it works like this, okay. Take your data, convert into embeddings and store into the database, okay. Whenever you got a query which is in natural language, also apply the same your pipeline, okay, which you use to extract the embeddings, okay. Take the same embedding pipeline, extract the embeddings of your query, and then take this and search inside your database, okay. So one of the popular model or multi-model model we use in industry, we use is clip, okay, from OpenAI, okay, which is used to extract the embeddings, okay. So that can be used to extract for both query and database documents, for example, okay. So this is one of the building block, I would say, of the systems like the rack system, okay, which is basically used to do the recommendations, okay, of your data, or query filtering we can do, okay. And examples of vector databases include like VB8, one of the example I would say, Milvus, Chroma, okay, or Qdrant also is one of the potential type of vector databases available, okay. Now in case of vector databases, still we have one limitation, okay. For example, if you want to say suppose in a document, okay, I mean you split the document, for example, and you make some chunks of the document and you store somewhere after converting into embeddings, okay. Now what is the relation between two documents? Is there any relation? Okay, those things is not possible to retain in case of any of these three databases, okay. It is difficult, okay, very difficult to do, okay. So for example, one part of the document, okay, may have some relation with the other part of the document, okay, and those relation and their attributes, properties is very difficult to maintain, and especially in vector databases, when your data is being converted to another schema or format, say vector embeddings, okay. So from big number or from document, you are shrinking and bringing down to a one vector which is small in length compared to the actual data, okay. So that way you are losing your data, and you cannot maintain the complete detailed understanding of what data was there before, originally, before converting to the embedding. And between the two documents, again the relationship is also very difficult to maintain. And also, if you have the inside of your document, if you have some description, say a traffic scenario, just for discussion, okay, so you cannot maintain details of what scenario it was. For example, how many count of pedestrians was there, okay, what are the cars and what are the different maybe color of the car, what is the traffic light color, whether it is green, yellow, okay, what is those things. These internal attributes are very difficult to retain, okay. This is the reason why we cannot do the fine grained search using any of these vector databases, okay. So this is the core reason why we need some alternate approach to all of these, okay. That's why there comes another type of database, what is we called graph databases, okay. So we will see next as a graph database, but this is the reason why only vector database is not good enough, or only relational, non-relational databases are not good enough when you want complete and comprehensive search, a fine-grained search for your data, okay. Great, yeah. So let's go for the next slide. Yeah, what are the graph database? Like we discussed, the graph databases basically it's basically it's a graph having nodes and their connections. Nodes, you can say every node can be a patch of data or chunk of data, okay, and the arrows or the connections basically retain their connections between them. What's the connection between them? Is there any relationship between them, okay. And also some properties at every node we can retain, okay. Say for example, pedestrian is one node, okay, just for discussion, okay. So you can say like what is that where this person work, what is the employee ID, what are the addresses, phone number, etc., wages, all those details you can keep adding about the person. In the same way, you can have another person and what's the relationship between them, okay. All those things and their interactions we can retain in order to study them, okay. Like in the medicines industry also it will very much useful to understand molecules and other properties, yeah. So yeah, so this is the reason why we need the graph databases. And yeah, so some of the leading available graph databases are as follows, okay. Okay, there are many, but I choose only four here just for our discussion, okay. Like one of the popular as Neo4j, okay. It actually uses like very user friendly kind of query language which is called safer query language, okay. And the best part here is it complies the ACID compliance, okay. And it is useful when you actually need a better and strong visualization of your graph, okay. When you write the query you should be able to see how it is working and what's the response. As a graph visualization, if you want to see, it is it provides very great visualization, but it comes with the cost of licensing, okay. But if you want to maintain locally on premises, it's good, you can deploy it, that's open source, the code is open source, you can use it, deploy in your premises and use it. But if you want to have online cloud application to maintain by the Neo4j team, then you need to pay for it. That's something we need to consider when you want to choose it, okay. So the other part, the next is Janus Graph. It's also one of the good and open source database exists, okay. There's no team to maintain, okay. You need to deploy by yourself on cloud, okay, in your premises, and then you can use it, okay. But it's also one of the good option to use. The best part here is it is Apache, it is very much friendly and easily integratable into the Apache ecosystem, okay. So that you can use as a backend Cassandra database for storage of your graph data, okay. And the use case for this is when you are having massive data and you want to increase upscale it very dynamically. In that case, Janus Graph is actually useful, okay. And it uses a data query language as Gremlin, which is also compatible with the ecosystem of Apache. Yeah, great. So again, we have another two more types of options, okay, which are maintained or managed facilities, okay, by Amazon, and the next one is by Azure, okay. So both are good, but I would say it will be useful when you actually you are having application running on AWS ecosystem, okay, or Azure cloud ecosystem. If you're maintaining, okay, in that case it makes sense. Otherwise it's, I feel, little costly, okay. Maybe you can comment what's your experience, okay. But yeah, so if you want to managed services, then go for Amazon based or Azure based cloud maintained solutions. Yeah, these are the possible solutions available. Great. Yeah, and the use cases like we discussed in our last video, okay, it can be used for multiple applications, okay. One of the major which is visible to us as social networking, okay, like Netflix, Facebook uses to understand the user, okay, what they are purchasing, okay, and what they will going to purchase probably, okay, based upon the history, okay. And also analyzing the customer, okay, and their interaction with the other, okay. So those things, further details we can do, okay. And also the recommendation of e-commerce content also is possible, okay. So these are the benefits we can do by using this, okay. And in the next video, okay, we will going to implement actually some of the queries and try to create the some data and create a database of graph, okay, inside neo4j, okay, and we'll see how the query response will come, and also we'll visualize the responses on the cloud aura instance. Okay, that's it in this video, and see you soon in the next video. Until then, have a nice day. Bye.